Here's the note set on stoichiometry and mole-to-mole stoichiometry. So stoichiometry is just the quantitative, or quantitative means how much, relationship among reactants and products. So the mole ratio is the ratio between moles of any two items in a chemical reaction. So it could be reactants or products. We must have a balanced chemical formula to do this. So in our first example here, first of all, we know our reaction type goes from two things to one thing, so we know that it's a synthesis reaction. Then we're going to look at the coefficient in front of the balanced chemical formula. So the coefficient in front means the number of moles of that compound or element within the reaction. So I have an unspoken 1 here, a 3 here, and a 2 here. So if I'm looking at the mole ratio of hydrogen to nitrogen, or to ammonia, I know that I have 3 moles of hydrogen to 2 moles of ammonia. So we're going to use that balanced chemical formula to figure out our mole ratio. The mole ratio of hydrogen to nitrogen then is 3 moles of hydrogen here to 1 mole of nitrogen. So hopefully we're able to see the differences between those mole values. So our problem here, how many moles of hydrogen are needed to completely react with 2 moles of nitrogen? My example looks a little bit different than your example, so please make sure that your example looks like mine. So you need to have hydrogen here and nitrogen here. So when we're doing conversions, we need to know 3 things. We need to know where we're starting, we need to know where we're ending, and then we need to know our conversion unit. So we know we're starting with 2 moles of nitrogen, we know we're ending with moles of hydrogen, and our conversion factor now is this mole ratio. So we've identified 2 different mole ratios. We could identify nitrogen to ammonia as another mole ratio, and so we're going to use that mole ratio in our balanced chemical formula. So the first thing that I'm going to do is start with, in my T-chart, what I know, which is 2 moles of nitrogen. So I'm going to start with 2 moles of nitrogen. So then I know what unit needs to go down here, and I know that that's moles of nitrogen. And then I talk to myself and I say moles of nitrogen. Can I go from moles of nitrogen to moles of hydrogen, which is what it's asking me to do? And in this case we can now, so this is a new conversion unit that you're learning, so we can go from moles to moles because we have the mole ratio here from the balanced chemical formula. So this is the first time we've had compounds or elements here not match, but this is called a mole-to-mole ratio. And so we know that we have 3 moles of hydrogen and 1 mole of nitrogen. So again, we can put elements or compounds like this in a T-chart because we know we have a mole-to-mole ratio. And so we're going to get that from the balanced chemical formula. So this is just really important. We basically have a new type of conversion. So mole-to-mole ratio here, and we're going to look at our values and put those in there so we know we have 1 mole of nitrogen and 3 moles of hydrogen. So then what I'm going to do is cross out my units and check to make sure, are my units in the units that it's asking me for in the problem? So I'm in moles of hydrogen to moles of hydrogen. So then I'm done, and just in like our T-charts at the beginning of the year, we're going to multiply across, divide underneath, and get 6 moles of hydrogen. So our next example, first our reaction type. We know that we have a decomposition reaction. And then our next question says how many moles of oxygen are produced by the decomposition of 6 moles of potassium chlorate. So we've got what we start with, which is 6 moles of potassium chlorate, and what we end with are moles of oxygen. So we're going to start out and put 6 moles of potassium chlorate in the upper left-hand corner of my T-chart. So there's 6 moles of potassium chlorate, so I know that I need to have moles of potassium chlorate down there. And then you ask yourself, can I go from moles of potassium chlorate to moles of oxygen? And I can because I have a balanced chemical formula. So when I look at this, I go moles of oxygen to moles of potassium chlorate. So what I like to call this mole ratio now is a very silly term. I like to call it mole city or moleville or anything like that. Okay, the map to mole city is the chemical formula. So it's a silly way to remember. Anytime I have a mole to mole ratio, I should be accessing the chemical formula for those numbers. So it's not always 1 mole. When we go grams to moles, we know that anytime we have grams to moles, it's 1 mole per the number of grams. But here, we need to reference those mole values from the balanced chemical formula. So I've got 2 moles of potassium chlorate and 3 moles of oxygen. So then I cross out my units, and I check to make sure, so moles of oxygen are there. Moles of oxygen is what my problem is asking me to get to, and so I'm able to do my math and I get 9 moles of oxygen. So there's our 2 example problems for stoichiometry going from moles to moles.